Hello, my dear student. Hope all of you are well by the grace of Almighty. Welcome all of you to my online physics class, and we are discussing 2020 board question solution. Okay, so today's our topic is SSC Mymensingh board 2020 question number 4. So let's boys, we see our today's creative question and we will try to solve this question step by step. So my dear boys, this is our today's CQ or creative question, and this is the stem of this question. Here A is a container of water of mass 250 gram at 10 degrees Celsius, and this figure is the ice of mass 120 gram at minus 5 degree Celsius. Okay, and the questions are, what is called heat capacity? Question B, explain why temperature of a favoring body is decreased when a band of wet cloth is used. Okay, and now question number C is, find out the temperature of the piece of ice in Fahrenheit scale. And question number D is, if the object B is released in the liquid of container A, what will be the final state of the mixture? Put your opinion with mathematical analysis. Okay, so my dear boys, this is our today's creative question. Now we will try to solve this creative question step by step. So, my dear boys, our question A is, what is called heat capacity? And the answer is the amount of heat required to raise the temperature of a body through 1 Kelvin is called the heat capacity of that body. Okay, I am repeat the definition again. The amount of heat required to rise the temperature of a body through 1 Kelvin is called the heat capacity of that body. Our question number B is, explain why temperature of a quivering body is decreased when a band of wet cloth is used. Okay, and the answer is, when a band of wet cloth is used, the temperature of the quivering body is decreased because wet cloth takes heat from the quivering body. Okay, as the specific heat of the water is 4200 joule per kg per Kelvin. It can help to relieve pain and swelling or cool a fever. So this is why temperature of a quivering body is decreased. My dear boys, now we will try to solve question number C, and the question is, find out the temperature of the piece of ice in Fahrenheit scale. Okay, so my dear boys, from according to the stem, we have given that temperature of the piece of ice is C equal to -5 degrees Celsius. Now we need to convert this value in Fahrenheit scale. Okay, so we know that the relation between the Celsius scale and Fahrenheit scale is C by 5 equal to F minus 32 divided by 9. Okay, so we can write we need to the value of F. So F minus 32 equal to 9 by 5 into C. Okay, so therefore F equal to 9 by 5 into C plus 32. Putting the value of this parameter, we can write here, this is the reading of Celsius scale, and that is -5 degrees Celsius. So put the value of -5, we get F equal to 23 degree Fahrenheit. Okay, F equal to 23 degree Fahrenheit. So the temperature of the ice in Fahrenheit scale is 23 degree Fahrenheit. Okay, so my dear boys, this is the process of converting the temperature Celsius scale to Fahrenheit scale or Fahrenheit scale to Celsius scale. Okay, so this is the answer for question number C. Now we will try to solve question number D. My dear boys, now we will try to solve the question number D. Here the question is, if the object B is released in the liquid of container A, what will be the final state of the mixture? Put your opinion with mathematical analysis. Okay, so from the stem we have given that mass of ice Mi is equal to 120 gram. After converting to kg, we get 0.12 kg. We know that dividing 1000 of gram value is converted to kg. Okay, and specific heat is given. SI is equal to 2100 joule per kg per Kelvin. Temperature of ice here, theta is equal to -5 degrees Celsius. So my dear boys, only for this type of math where we are use the difference of temperature, in this case we don't need to convert the temperature into Kelvin unit. Okay, here you can directly use the degree Celsius value, because the difference of temperature of unit in in Kelvin scale and Celsius scale is same. Okay, now we also have given that mass of water MW equal to 0.25 kg. The specific heat of water is 4200 joule per kg per Kelvin, and temperature of water theta W equal to 10 degree Celsius. Here let the temperature of mixture is theta. Here if we release the piece of ice into the water, then the ice will so my dear boys, if we put the piece of ice into the water, then the piece of ice will gain heat in 3 steps. Okay, firstly the ice will gain heat and it will convert to 0 degree Celsius ice. Then 0 degree Celsius ice converts to 0 degree Celsius water, and 0 degree Celsius water will gain heat to reach a temperature of mixture, and that is theta, and water will release heat into one step. Okay, and the step is the 10 degree Celsius water will convert to or turns to the temperature, the mixture temperature water. Okay, so here the main point is here the ice will gain heat in 3 steps. Okay, here is the first step where after gaining heat the ice will first convert to 0 degree Celsius ice. Okay, so we know that heat gain Q equal to ms theta 2 minus theta 1. Here m is the mass, s is the specific heat, and theta 2 minus theta 1. Suppose such that final temperature minus initial temperature. Okay, so we can write m ice s ice 0. Okay, final temperature for this step final temperature is 0 degree Celsius, so 0 minus theta ice, plus in this step when the ice converted to 0 degree ice to 0 degree Celsius water where only state is changed, in this state the ice will gain a latent heat that is called latent heat of freezing point. Okay, so here the heat gain is m ice, mass of ice, into LF, latent heat of freezing point. Okay, and finally the 0 degree Celsius water will turn into theta degree Celsius water. Okay, so m ice into SW, here the state is water. Okay, then theta minus 0. Okay, here theta is the final temperature minus 0 degree Celsius. Okay, equal to, according to the theory of calorimetry, we know that heat required to melt equal to heat supplied. Okay, heat required to melt equal to heat supplied. Okay, so heat is gained by ice, but heat is released by or supplied by water, and the step is only one. Okay, here the 10 degree Celsius water will turn to theta degree Celsius water. Okay, so the heat supplied by the water will be mw sw theta w minus theta. Okay, so my dear boys, putting the value of this parameter we get, okay, putting this value we get these values, and we can write here, space is short. Okay, we can remove this part in this time. So my dear boys, after calculating these parts, we get the value of theta, or the temperature of mixture is minus 20 degrees Celsius. So the value of this is negative. So we can say that the whole ice will not melt. Okay, only a portion of ice will melt, and other portion of ice will be in the water, and the temperature will be that is 0 degree Celsius. Okay, now in this part we will determine how amount of ice will melt. Okay. So, my dear boys, the negative value of theta indicates that whole amount of ice will not melt. Only a portion of the ice will melt, and the temperature of the mixture will be 0 degree Celsius or centigrade. Water and ice both will be exit at that temperature. Okay. So, in this case, my dear student, the amount of ice melted be Mi, and here in this case the temperature of mixture will be 0 degree. So again the ice will gain heat and the water will release heat. So according to the theory of calorimetry, we can write the heat required to melt equal to heat supplied. Okay. So in this case it will be in 2 step. Okay. So this is our formula for this step, and after putting the value of this parameter we will get the mass of ice which is melted is 0.0275 kg, or we can write Mi, or the mass of ice which is melted is 27.5 gram. So we can write 27.5 gram ice will melt and rest, or 120 minus 27.5 gram or 92.5 gram will remain an ice of 0 degree Celsius temperature. So my dear boys, this is our answer for question number D. Okay. So my dear boys, this type of math is very important for SSC board exam. You should try this type of CQ question, creative question very carefully. Okay. So my dear boys, this is all for today, and in our next lecture we will try to solve another CQ question. Okay. So until then boys, thank you.